Okay, this is going to be over, this is going to be a velocity graph, since it's going to be meters over seconds. So when you're looking at this, my prior one showed a position time graph. Position time graphs are velocities. This one is just meters. This is a standard velocity graph. Again, I'm kind of looking at the side, I'm looking at the other axis to determine what I'm doing, and that kind of has to show my mindset as far as answering these questions. So, let's say I'm looking at these 2 points here. Are they going to be at the same magnitude of velocity? Well, is the velocity going to be the same magnitude? You have to, again, picture what's going on here. When we start at this point, this one is actually going slower than this one. Well, let me think about that one. Actually, this one's going faster than this one, but they hit the same point. It's kind of a little confusing when you're looking at it at the beginning. But basically, at the same point, are they going to be in the same magnitude as far as your acceleration? Well, this one started out going slower than this one. So this one is actually kind of going a little slower at the beginning, which kind of bore out on this part here. This one's going faster. So is their velocity the same magnitude? No, it can't be because of the positions that they started out with. I hope that makes sense. Now, as you're going through this curve, you're going to notice that this one is traveling slower than this one here. But near the end, it's starting to pick up speed and overpassing it. So in this position here, object B is actually overpassing it and going at a higher velocity than object A. So that would be your answer there as far as this. So object B is traveling faster here than object A. A started out ahead of it, but then all of a sudden B just speeds right past it. So is the velocity going to be the same magnitude at either of these points? The answer would be no. They're not at the same magnitude. Why? Because B is overpassing A, so it's got to be traveling faster. So that would take care of that type of question. Again, you have to put that in your own words. Let's see, I have two identical ones passing on the same parallel horizontal track. Do either of those change position? That is a trickier question, because you could look at this as, well, maybe they are, because this one traveled like this, and then it passes it. It's got to be on the same track. We're not really looking at this as two separate tracks. We're just, yeah, we are. We're looking at two separate tracks. This one's moving at a constant. So if it's moving in the same direction, yes, that would be constant. And it would be on the same track for A. On this one, no, that doesn't work. First of all, you have this curve here. Many variables could happen this time. So does it change as far as the direction? On this one, for B, yes, it could be changing direction. So I would say B is changing direction, and A is not. Maybe B decides, well, I got to speed up and get past A, and he'll take a shortcut. But again, B is changing direction because the irregularities irregularities in its curve. A is a constant because it's a constant line. Again, you got to be a little bit flexible in your thinking. Okay, on the other one, as far as where they are in the same position. Well, when they're in the same position, again, you'd have to kind of look at it as being not a change in direction. Being in the same position is kind of weird too as far as the question. Will they be in the same position? Maybe not. But let's say again he's traveling a different route. If they're in the same position, it's going to be where they intersect. So let's count this as, let's see, A and point B. Not to be confused with the object A and B, but in the same position, that's going to be at point A and point B. So those are going to be the intersecting ones. Hopefully that answers your questions. Again, this is a velocity graph because it's meters and seconds.